Two algorithms, same skeleton, different details in a few specific steps. You could copy the skeleton twice and customize the parts that differ. But then, you're maintaining two copies of the same control flow. One diverges silently, and you won't notice until it's a bug. Template method solves this. Define the skeleton once in a base class and let subclasses fill in only what varies. The abstract base class defines the template method, the overall algorithm. It calls abstract methods for the steps that vary and concrete methods for the steps that are fixed. Subclasses implement only what changes. The template method itself is declared final. Subclasses fill in the blanks. They can't reorder the skeleton. The invariant is protected. A data processing pipeline. Every report follows the same flow. Open the source, parse the data, process it, format the output, close the source. Open and close are always identical. Parse, process, and format vary by report type. The base class implements open and close once. Each report subclass provides parse, process, and format. The template method sequences all five. Subclasses never have to think about order. They just implement their piece, and the skeleton calls it at the right time. Template method often includes hook methods, concrete methods in the base class with empty bodies. Subclasses override them when they need to inject behavior at a specific point and ignore them when they don't. Flexibility without forcing every subclass to implement everything. Spring's JDBC template is a real-world example. The database lifecycle is fixed. You provide the query and row mapping as the variable steps. You've likely used this pattern without knowing its name. Template method versus strategy. Both vary the algorithm. Template method uses inheritance. Variation lives in subclass overrides. Strategy uses composition. Variation lives in injected objects. Use strategy when you need to swap algorithms at runtime or mix behaviors. Use template method when the skeleton is stable and the subclass relationship already makes sense in your type hierarchy. The trade-off to name: template method locks the algorithm structure in the base class, powerful for consistency, rigid when the skeleton itself needs to change. In modern Java, strategy with functional interfaces is usually more flexible, but template method is everywhere in frameworks, so recognizing it when you see it is part of the job. Define the skeleton. Delegate the details. Template method is control flow by inheritance. Use it when the structure is sacred and only the steps are not.